Hi everyone, Assalamualaikum. In this video, we are going to discuss definition of differentiation, or the other name is the first principle, right? We use this formula, limit h approaches 0, fx plus h minus fx over h, to find f prime x, right? Learning outcome. At the end of this session, the students should be able to find f prime x using the definition of derivatives formula or using the first principle, right? We look at example 1. Use the definition of differentiation to find f prime x for fx equals to square root of 1 minus 3x. Alright, let's say we want to check the final answer. Okay, let's say we differentiate using generalized power rule. Okay, from fx equals to square root of 1 minus 3x, we can write into the form of bracket 1 minus 3x to the power of half using the properties of indices. Okay, and then from here, every time when we have bracket with any exponent, okay, any integer or fraction, negative integer, positive integer or fraction, we can differentiate using generalized power rule, right? So using generalized power rule, f prime x equals to half and then 1 minus 3x to the power of negative half times negative 3. How we get this? We look at step by step, right? So first, from here, we get here, we move power to the front here, right? And after that, from here, we copy in bracket, means the original bracket here, we just copy, alright? And then from the power here, how we get this? Power minus 1. So half minus 1 equals to negative half. And then don't forget to put times negative 3. How we get negative 3 here? We differentiate in bracket. We differentiate this or this. Okay, in bracket this. So we differentiate 1 equals to 0. We differentiate negative 3x equals to negative 3. That's why we get this. Alright? And the sign here should be multiplication operation. Alright? Then we can simplify. Okay? Negative 3 times half. So we get f prime x equals to negative 3 over 2 times, using the properties of indices, we can write equals to 1 over to the power of negative half. We can move down using the properties of indices. When we move down, it will be bracket to the power of positive half. And bracket to the power of positive half means square root. Right? That's why we get this. Then we have fraction times fraction. So we just multiply numerator and numerator. And we multiply denominator and denominator. So we get this. Okay, negative 3 over 2 times square root of 1 minus 3x. This is the final answer for f prime x if we differentiate or if we find f prime x using generalized power rule, right? But in this case, the question is use the definition of differentiation, okay, to find f prime x. Means you need to use limits formula, right? This technique we just use to check the final answer, right? So that our answer when we use definition of differentiation is not ke laut. Alright? Got it? Right, this is the final answer. f prime x equals to negative 3 over 2 square root of 1 minus 3x. We find this using generalized power rule. But if the question states the definition of differentiation, so we need to find f prime x using the definition of differentiation, where f prime x equals to limit h approaches 0 fx plus h minus fx over h. Okay, from this formula, first we can identify fx and then find fx plus h. Okay, so our fx equals to square root of 1 minus 3x. After that, we need to find fx plus h. Okay, so we get square root of 1 minus 3. We replace x by x plus h. Okay, we must put in bracket here. Okay, and after that, we expand this, so we get equals to third 1 minus 3x minus 3h. Right? After that, we substitute fx and fx plus h into this formula. So, after we substitute, we get this. F prime x equals to limit h approaches 0. We replace fx plus h equals to third 1 minus 3x minus 3h. And then in between here is minus sign, right? And then we replace fx equals to third 1 minus 3x. And then over h. Okay? Alright, when we solve limit, let's say we try using direct substitution. Okay? If we use direct substitution, we replace h equals to 0 into variable h. Okay? Not into variable x, because this is limit h approaches 0, not limit x approaches 0. So that's why we must replace 0 into h, not into x. Right? Is it clear? Alright, if we use direct substitution, we plug in 0 into h here. So we get third 1 minus 3x, and then minus third 1 minus 3x. We minus the same function, so it is equals to 0. And then 0 here for h here. So it means that in this case, if we use direct substitution to solve this limit, we will get 0 over 0, which is indeterminate. So what should we do? Right, in this function, we have third symbol. So, if the function is given in third symbol or radical symbol, and if we use direct substitution, the answer gives 0 over 0, we need to multiplying by the conjugate. Right? Right, from here, we multiply by the conjugate. Okay, we need to multiply top and bottom by the conjugate. Why? Because when top and bottom are equal, means it is equals to 1. And 1 multiplied by any value or any function, it doesn't change the original value. That's why we need to multiply top and bottom by the conjugate. Right? After we multiply top and bottom by conjugate, then we get this. Okay? So we multiply numerator and numerator. So we get this. And we multiply denominator and denominator. Okay? Then we get this. Okay? Look at this. From here, we have same function, but in between here is minus. And in between here is plus. Alright? Alright, the conjugate of this function is, we need to change the plus, the minus sign here. We change to plus. Okay, no need to change this minus sign because this minus sign inside the third symbol. So consider one term. Okay, we only change the sign outside third symbol. Alright? So after we multiply numerator and numerator, so we get this. From here, it is conjugate each other. So when we have conjugate each other, So we can simplify using a plus b times a plus b equals to a squared minus b squared, right? And from denominator here, it is not conjugate each other. So no need to expand, right? Right, after we expand this using this formula, so we get this. F prime x equals to limit h approaches 0. From here, when we compare, our a equals to third 1 minus 3x minus 3h. Okay, and then from this formula, so we can write third 1 minus 3x minus 3h bracket squared, and then in between is minus, and then our b equals to third 1 minus 3x. Okay, so from this formula, so we can write third 1 minus 3x bracket squared. Right? We only simplify for this numerator only because this numerator is multiplication between conjugate. Right? Right, after that, we can simplify third and squared here. So we get this. Okay. And then in between is minus, and then we simplify third and squared here, so we get this, no more third and no more squared, right? And to avoid error, you must put bracket symbol, especially when in between here is minus sign. After minus sign, more than one term, you must put bracket to avoid error, right? From the previous slide, we get this after we simplify third and squared, okay? And then we can expand minus sign here with the function in bracket here, okay? So we get 1 minus 3x minus 3h minus 1, and then minus minus equals to plus, okay? Plus 3x, okay? And then we no need to expand denominator, remember, because this is not conjugate for each other, right? After that, we can simplify positive 1 and minus 1, which is equals to 0. And then negative 3 and positive 3 also equals to 0. So after we simplify this, so we get this. F prime x equals to limit h approaches 0. Now our numerator only negative 3h. Okay, and then but we still have the same denominator, okay, over h and then bracket this function, right? And then from here, we can simplify h from numerator and h from denominator. So we get this. F prime x equals to limit h approaches 0, negative 3x, negative 3, no more h, okay? And then over third 1 minus 3x minus 3h plus third 1 minus 3x, no more h here, right? After we success simplify h from numerator and denominator, then we can use substitution method. Okay? We substitute h equals to 0. Remember, we only can substitute h after we done or we success simplify h from numerator and h from denominator. Okay? Alright, so from here, after we substitute h equals to 0 into this function, so we get this, negative 3 over third 1 minus 3x minus 3 times 0 equals to 0. So no more minus 3h. And then plus third 1 minus 3x. Okay, remember, when we use direct substitution, no more limit expression. That's why there is no limit here. Okay. Right, after that, we need to simplify this. How to simplify this? Right, from here, we have same term. Okay. Alright, let's say if we have y plus y, it is equals to 2y. If we have a plus a, it is equals to 2a. How about if we have third 1 minus 3x plus third 1 minus 3x? We have the same term. Okay. So it is equals to 2 and then Set 1 minus 3x. We just follow this formula or this concept. Alright? So after that, we get f prime x equals to negative 3 over, after we simplify this, so we get 2 set 1 minus 3x. Okay? And then we compare with this answer. Okay? This answer we get when we find f prime x using generalized power rule in the previous slide. Okay? Right, from here, the answers are the same. Means that this answer is correct. Okay, but this one we use definition of differentiation. And this one we find f prime x using generalized power rule. Alright? When we compare, it is equal. So means the answer is correct. Got it? Alright, I repeat, if the question states the definition of differentiation, we must find f prime x using limits formula. Okay, but if the question didn't mention the word definition of differentiation, to find f prime x, we can find f prime x using any technique, right? Such as generalized power rule. Okay, but if we use general power rule to differentiate, we can check the final answer, right? Got it? Coming up next, definition of differentiation, example 2. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.